Hi, everyone. Please settle in. We'll get started in just a minute here. Thank you for joining us today. All right, let's go ahead and get started. Hi, everyone. My name is Trish, and I'll be your host for today. For our event, we are discussing Hack My Misconfigured Kubernetes, brought to you by Snyk and hosted by VIB. Today's webinar will be about 45 minutes, followed by 15 minutes of Q&A. Please use the Q&A button if you'd like for your question to be seen. And please note that we'll be answering all questions at the end. Without further ado, I'd like to introduce today's speaker, Senior Developer Advocate at Snyk, Eric Smallings. Turn it over to you, Eric.
Thank you so much. Welcome, everybody. As she just said, we are here to talk about Kubernetes and hacking a misconfigured cluster. My name is Eric Smalling. I am a developer advocate at Snyk. We are a developer-focused software security scanning tool company. And just so you know where I'm coming from, a little bit about myself, I'm a developer here in the North Texas area. I have been doing software development here, mainly in the travel industry, for about 20 years, followed by about a decade of consulting, usually in the development tools space, CI/CD, test automation, build automation. And during that time, I found Docker way back in the early days in 2013, before we had orchestrators or even any of everything was scripted back then. I have been a Jenkins ambassador, ran the Jenkins meetups here in Dallas for a while, and most recently been added to the Docker Captains group and have the 3 main certifications in Kubernetes, in case you care. I am Eric Smalling on most socials and LinkedIn and all that. If you care to follow me, the slides for this presentation I will post to SlideShare, and we'll put that out on my Twitter and LinkedIn feeds if you want to get them. You should also be getting an email from us afterwards with a copy of the recording and the slides and whatnot. So with no further, one other thing. So this is a pretty dense presentation. I'm going to get to the questions at the end, but please use the Zoom Q&A feature to queue up the questions. And I will try to address them at the end. Should have about 10 to 15 minutes to do that. If I look up, and I'm looking at my monitor where the chat is right now, if anything comes up that I can deal with as we go, I will, but otherwise I'll get to them at the end. So today we're going to be talking about how a combination of application vulnerabilities and misconfigurations can allow an attacker to spread the blast radius of their attack or their exploit. This is a pattern that almost every major exploit recently has followed. Application vulnerability gives an attacker the initial foothold, and then application or infrastructure level misconfigurations often allow them to spread into other parts of your system. Today, we're going to be talking about this in the context of Kubernetes, obviously. We're going to walk through how we can go from exploiting an application vuln to basically owning a cluster. Now, to set the scene here, let's imagine that we have an application that's vulnerable somewhere out on the internet. We don't know much else about it other than that it has a particular vulnerability. We've determined that through some scripting or some kind of poking at it. And for the purpose of this demo, this is going to be a mock-up. The vulnerability here is baked into this Flask app I wrote, and it's going to let me run remote command execution vulnerability type things on the server where the application's running. It's going to be like I said, it's a simple Flask app that's contrived, but it's an example of what an actual RCE type vulnerability will let you do. These things are found in platforms sometimes, like Tomcat, or I recently saw one in the Python Celery framework. And what they allow is for an attacker to pass a malformed or specifically crafted, like an HTTP request or something, that allows them to run commands directly on the server. Now, as we go, I have this graph we call the timeline of doom. And as we go, it's going to track the different things we find and how they are like dominoes feeding towards a larger attack. So, enough slides. Let me get over to my demo. So, here we are in front of, and just to kind of set the scene here, this is running on a Kubernetes cluster, and for simplicity's sake, I'm just using kind, which is Kubernetes and Docker. It's a very small Kubernetes, basically it's for running Kubernetes on your desktop. And I have it actually running on another laptop sitting next to me that is Intel based because I actually found some bugs in the M1 implementation, which is the screen you're looking at. So if you see my host name is Intel, that's just because I have a host entry up to hit that. That being said, we have the application. Imagine we have figured out that this is a vulnerable application through some script or proof of concept code we've written against it. And a normal RCE wouldn't be as friendly as to provide me with such a inviting screen here. But the first thing I might be interested in looking at, and in this case, what I found is if I enter something here, let's say host name, command equal host name, and it's going to spit out the output here on the page. The first thing I might be interested in looking at, though, is what are my environmental variables? Here you're seeing for the environment of the Python, in this case Python web app, this is the environment variables that are set. And we can see immediately, grow the font a little bit there for you, that there are a bunch of Kubernetes named ones, which tells me some things. First, that tells me we're probably in a container and we're running in a Kubernetes cluster. It's kind of obvious. With some of the values in here that are interesting to me. So I see a Kubernetes port. This IP address and port, this is the Kubernetes API server, the control plane, from the point of view inside the clustering for this pod that this is running at. So I should be able to potentially, if I can get to that, that's going to be the API server. I also see things like, where is it? Here's web admin service port. That tells me that this is likely running, this is almost definitely running as behind a Kubernetes service that exposes on a port 5000. Now I'm hitting this on port 80, so that means there's probably also some kind of like an ingress or something in between me and it. But just interesting information that you can gather through this. Let's see, what else could we do here? So let's look at our timeline. So we know that we have an app vuln. We know that we are able to connect to it on port 80, and it most likely is running on a service at port 5000. And we know that we can see the internal IP of the API server. Let's see if we can get at the IP address of this pod. So I'm going to copy this and open another tab. And I'm going to type IP space A. That's the URL encoded version of that. And here we see the output of IP space A. And this IP address, actually it's a mask, is the IP of this pod and the mask of the subnet that this node is giving that the pods are getting here. So that is interesting info. That gives me the IP address of the pod. And the next thing I want to take a look at here, go ahead and get another tab open. I'm going over to my notes to copy because I don't want to type a long thing here. When you start up when you deploy a pod and you deploy an application in Kubernetes, you usually are going to be using a service account that all the bits of your application are going to be under. And by default, that service account gets a token. And oops, I duplicated my command in there. I'm going to, sure enough, I'm going to cat out the default location for that token, and there it is. Now, this is the first misconfiguration piece I want to call out. Service accounts by default will auto mount this token into any pod that gets created with them. That is not necessary unless your pods really need this token to get at things, and you really should disable that. And when you declare your service account, you can say auto mount, I can't remember the exact string right now, but auto mount, here it is, auto mount service account token false. If you set that in your service account, this won't get auto mounted, but by default it is, and sure enough, it's still there. So that's interesting. So we have a token available inside the pod. What can I do with that, though? So I'm going to check something else here. I want to see if what do I want to see? Let me copy again this string and open another tab. I'm gonna have a lot of tabs by the time we're done. I want to see if I've got curl available to me. A lot of times, curl, and just put in google.com. I do. So this means that curl is available in the file system in the container that's running this app. And I can also see that I got a 301 back, which means I actually was able to connect outside to Google, which gave me the redirect it normally would give. So two more pieces of information. I have curl and I have internet connectivity, at least to Google. But I want to do something else with curl that is a little more pertinent to this discussion. Let me copy a long string over here. I'm going to replace the Google piece with this long thing, and I'll explain what it is as I pull it up. So I'm curling that endpoint we saw in the first tab in the environment, the Kube API, and I'm asking for the endpoints in the default namespace. That's what this REST call is doing. Now I'm authenticating to the Kube API with that token at that location, and because that's in the standard place, I assume that the CA cert is in the standard place, and it is. I suppose I could probably just do curl-k to ignore that, but I didn't. So I'm able to get at the endpoints list from the point of view of the default namespace. And if you look here, now this is where it's going to, because I'm running in kind, this is going to be a little different than a real world cluster, like if you run kubeadm to set one up yourself. This IP address in a real world cluster would be something that's externally visible. That would be the endpoint IP for what kubectl or any client of your cluster would use to get at it. And I would be using that. So for my purposes, because this is running in kind, it's kind of hacked together, I'm just going to be hitting a local IP for it. But that's where I would get that in a real, like if I was running at a company and I had it on in the network. So that's interesting. So let's go back to our little graph here. So we now know that we can connect from the pod using that token to the internal IP, and it allows us access to the endpoints API. So let's go back to here. Next, I'd like to start doing things without having to use this RCE anymore. It's gotten me a lot of good information, but I'd like to connect directly. Now I've got K as alias to kubectl, so if you see me type K, that's because I'm too lazy to type kubectl. But if I try to get pods right now, I don't have any kind of config setup. This is just running locally. I just want to show you that I'm not connected at the moment. But I have a little helper script that will craft a kube context given a token. So if I come back to this tab, I'm going to grab that pod's service account token, paste it here, and using my, like I said, this is a local thing, so it's got my just a host entry. So now if I cat that config file it just created, you'll see that I've got a context I can use. So I'm going to export kubeconfig to that. Now if I do get pods, it's going to try to connect. Now I'm getting an error, but this is actually not bad. What this is telling me is that pods, a get pods is forbidden for this user, which is the service account for the web admin service account in the secure named namespace. Don't take me as saying secure namespace, because namespaces aren't a security boundary. But there's a namespace named secure, another bit of information. And it's not allowed to view things in the default namespace. Well, since I know that there's a secure named namespace, I wonder if I can get pods in that. And sure enough, I can. So you can see that when I did that, I can see there's a single pod running named webadmin, followed by its unique ID. So let's see what else I can do with that. So clear my screen. I'm going to ask kubectl to show me the list of permissions I have for this token, if I pasted that correctly. So here, this is the default namespace. I didn't specify a namespace. So this in the default namespace, we can see that the endpoints resource, I have wildcard on the verbs there, but I really don't have much of anything else here. If you've looked at this list before, there's lots of other things I could have. But that makes sense because I was able to get the list of endpoints through the RCE. what if I did the same command into the secure namespace? Here I have the wildcard on the resources. So I have for all resources, I pretty much have all the verbs. I can create, get, watch, list, all of these things for all resources in the secure namespace. So that's pretty powerful. While I'm looking at this, there's another tool you can use to um, look at these things in a little prettier way. There's a list of plugins for kubectl called the Krew, K-R-E-W plugins. And there's one called that I already have installed called Access Matrix. Now, in my testing of this, I found that I think I have there's an ARM M1 issue with this plugin. It gives me a bunch of empty lines here. Ignore that for the purposes of this demo. But you can see all these resources, and I have just X's on all of them because I don't have access to them in the default namespace. If I ask for the same thing in the secure namespace, this is just another view of the CANI list, but now it's showing me all these different resources that are there, and I have list, create, update, and delete access on all of them. So just another view on it. It's just a kind of a cool plugin. Hopefully they fix the UI issues in M1 soon. Let's see. That was interesting, but let's get back to what we're doing. The next thing we are going to look at is, given that I have that access, let's update our list here. So we know we can access via the external IP using the token that we scraped out of the service account token. And we know that we have a namespace named secure that this pod is living in. And we also have a default namespace. We don't know what's in it, but we know it's there. I'll get to this slide in a second. So let's go and see what we can do with the rights that we have. I have a pod of my own I'd like to see. Actually, before we do our own, let's see if we can exec into that pod. So I'm going to go into the secure namespace, into the web admin, and let's see if we can get a shell in that. We can. Here I am. So let's do it. Who am I? So I'm the web admin user in the pod that's running in that namespace. That's good. The fact that I'm not root is a good sign. That means that whoever developed this, the image for this, or at least the deployment for this, is not running as root. And that is one thing you can use to mitigate issues, because even if you're in a container, root can do more things than you want, most likely. So next, let's see, can I edit files in here? I can. So you can see I've created a test file in this directory. That tells me that the root file system here is not set to immutable. It's not set to read only. So if we go back to, I got a couple slides we'll go through here. We have we have roles set up here that are very permissive for the secure namespace service account. And this is very common, actually. Developers often will create a an RBAC. They'll use RBAC, which is good, but they'll say, hey, in my namespace for my application, the service account that's doing stuff in here needs to be able to do things. So I'm just going to give it blanket access to whatever it needs to do. That's a little overly permissive. The other aspect of this is that because that application team is probably only thinking about their namespace, they might not have applied anything to the default namespace. And the cluster admins, it's up to them to have done that. And we're going to take a look at that in a second. So we know that our role has a lot of permissions in this namespace because I'm able to do some of these things. The read-write file system issue is when you have a mutable file system, it allows anyone who gets access to it to start modifying it and doing things like downloading their own scripts, changing configuration of your application, erasing their tracks if they're making changes to things. And it's very simple to make things read-only. All you have to do in Kubernetes is add a security context, read-only root file system true. This basically tells the container engine, don't add the read-write layer above the read-only image layers, effectively giving you a read-only file system. Not only is this a good deterrent to limit what hackers can easily do in a container, It also is just good practice in microservice, 12-factor architecture. One of the factors is immutability. It helps you make your containers are a lot easier to schedule across the cluster and move around when they need to, because they don't have, they're not containing state. So this is a good practice. So we know that, oops, I'm getting ahead of myself on the slides. So we know that we can do these things. Let me get back out of this container. Let me try to run my own pod in here. We can kind of see a little bit more about these permissions that I have that might be too liberal. So if we, again, look at, which one do I want to do here first? We've got a YAML I have in this directory that I call root pod YAML. So this is a very simple pod definition that's going to start an Alpine image, just a standard official Alpine image, which by default runs as root. Now this is just going to sleep. I just want to see if I can start this container. I'm going to do apply -f demo YAMLs root pod into the secure namespace, and it says it created it. But if I get those pods and look, sure enough, I have an error. It's saying I can't create this. Let's do a describe on it. At the bottom of the describe, we can see container has run as non-root and image will be run as root. Interesting. So when Kubernetes, when you specify run as non-root true, false, true, my Boolean's correct there, you're telling the kubelet to, unless I'm specifying a specific user, look at the default user in the image. If it's UID 0, that's root. And the kubelet will respect this and say, I won't start that container for you because you told me not to. But what's interesting, if I scroll back up to this definition, I didn't say that in my there's no security context here where I would normally declare that. So what we're seeing is most likely a pod security policy has been implemented to stop that from happening. In fact, I know that's what's happening because it's after deployment time. So there's various ways you can stop that. We've deployed it. The API server accepted the request, but the kubelet is denying the. It's as if I had set that security context. So that's good. You should stop people from running as root. So given that, I've got another one. Let's let me copy. Actually, I'll just clear my screen. Instead of root pod, I've got another one I'm going to try called non-root priv.yaml. So this one is a container of our own that my buddy Matt and I have written that has some interesting stuff we'll see in a minute, that tries to start as user 999, which is not root, but it's going to try to start a privileged container. And privileged containers, by default, containers are not privileged, but what privileged containers do is they give the contained process access to devices on the host. You're effectively, it's like being root on the host. So you should not ever do that normally, but let's see if I can. So let's apply demos non-root. Oops, get my cursor in the right place. Priv. Oh, that was denied right off the top. And sure enough, it's saying it's forbidden, pod security policy, unable to admit pod, privileged containers are not allowed. So right away, we now know we're using pod security policies to block things, and rightfully so. They've set it up to say, no, you can't do privileged containers. What are you, crazy? So that's good. However, there are more than one way to do these kinds of things. So I've got another one, of course I do, called non-priv. And you can see this one is more simple. It's the same container image. It just doesn't have the privilege on there. There were some other things in the other manifest I skipped over. We'll look at those in a minute. But for this one, let's see if I can deploy it. And let's see if it's actually starting. It is. So you see the sneaky pod. It is running. Now, instead of execing into that, I'm going to show you what that started. There's a port 8080 service running in that, and I'm going to use kube port forward to get access to it. So since I have the token and I can get into this cluster, what port forward, if you're not familiar with kubectl port forward, it basically sets up a proxy, if you will, a forwarding, tunneling of port 8080 in this case, inside the Snyk pod that's running in the secure namespace to 8080 on my local machine. So if I hit localhost 8080, it's going to hit whatever's listening inside the container at that. So let's go back here, open another tab, hit localhost at 8080. And this is GoTTY. This is a tool that you can install and run that is a Go-based TTY server. So I basically am getting a shell inside the Snyk container that I've started in that namespace. And if I do who am I am the Snyk user. Host name, which is obvious from my prompt, is Snyk. So this is a lot easier than dealing with the RCE interface that I have. What can I do here? Well, I'm not root, but I know that when I created this container, the image for this container has sudo in it. So if I type sudo su, I can become root. Why is that? I thought privileged and roots were being restricted. Well, this is because pod security policies, when you set them up, you can say don't allow privileged and don't allow users that are UID 0, but allow privilege escalation, which is a separate security context, is not redundant. If just because you don't allow privileged or root doesn't mean you get privilege escalation disallowed. In fact, the default for allow privilege escalation is true, which is unfortunate. And it's actually not as clear as it probably could be in the documentation. But what privilege escalation means is exactly like it sounds, elevated privilege for a process. So that's why sudo is working here. Now, it doesn't have to be the actual sudo command. It could be just a command that I've set the SUID bit on, and it can become elevated to root. The moral of the story is you should set this to false. Make sure that people aren't able to escalate privilege, because most likely they don't need to be doing that. Your process probably doesn't need to be doing that in your container, especially if you're just writing a business application. So we now know not only does my RBAC role give too much permission so that I can do things as that service account that I probably shouldn't, but now I know my PSP is not disallowing privilege escalation. Now, before we go any further, I know that PSPs are deprecated and that they are going away in a couple more versions. I think 125, they actually get removed. There are other tools to replace them, like pod security admission, which is in beta, as well as other admission controllers. But PSPs are still actively used by people, and if you're going to use them, make sure you're using them with enough restrictions. So that's interesting. I didn't show it, but if I had gone into the web admin container and tried to sudo's not even installed in there, which is a good sign. I skipped a step of my demo. Okay, so what else can we do while we're in here? I'm going to pull ifconfig just because I want to see. So this is 10.244.121 where I'm running. Now, I'm going to jump out of root again for a second to show something else. There's a tool called Nmap, if you're familiar with it. This is a tool, a diagnostic tool that allows you to basically poke around your network and see what's running, what's visible, what's listening. I want to use that IP, basically the mask for this IP. I want to scan that network for anything listening on port 5000. Now I exited root because I want to show that you cannot run this as root, as non-root, sorry. It requires root privileges. So this is one of the reasons why you don't want people to be root, because they can use a tool like this. And what they can do with it, and this might take a moment because, there we go, is they can find, what I've just did is I searched my subnet for any services running on port 5000. 5000, if you remember, is what we saw in the environmental variables as what this service is running behind. We know from this that .18 is the initial instance, the pod that we hit, right? So if I go back here and look at what I've found, is I've got there's .18, so that's that one. I've got another one at .19. There's only one pod running in the secure namespace, so it's not like it's we've got two scaled up, or we've got another 5000 listener in that namespace. So we've got something else listening at 5,000 somewhere in this network, which was most likely this cluster, at 5,000. I'm going to venture a guess that somebody's running another copy of this app somewhere, and I want to figure out where. So that's all interesting information, but I want to see if I can get to that one, the one that's not in the secure namespace. And to do that, first, here in this Snyk container, I'm going to start up a tunnel using socat, socketcat. I'm sure it has lots of uses, but I use it for tunneling. And I want to point it at, what did I say? .19. So we're going to hit this instance of on 5,000. And what I'm doing is I'm setting up a listener of 5001 in the Snyk pod that will send my traffic to this other listener. There's that. Now to do that, I'm going to need another port forward. So I'm going to reach into the Snyk pod, this time at 5,000. Oops. Oh, sorry. Got to export my kube config to do that. So now I have two port forwards going in, one for the GoTTY session and one for that 5,000 port. Let's go back here and see what we get when we hit localhost at 5,000. Nothing. Oh, live demos, folks. Let's try that again. I promised this worked a moment ago. Excuse me for a second. Oh, you know what? Oh, I want 5001. Did I set the wrong one? Yeah, sorry. I'm listening on 5001, not 5000. No wonder. Just proof that it's live, not Memorex. So we hit 5001. No, it's 5001. There we go. Now I don't need this the web admin context because I'm not behind the ingress and I'm hitting it directly and it happens to be where the web server is. So let's see if this one's vulnerable. We'll do the same command equal env just to see if that works. And it does. So we've got another instance of the app running somewhere else in this cluster that is also vulnerable. That's good to know. So let's do the same thing we did for the initial vulnerable app. And I'm going to change this instead of env. I'm going to see if I can get at the service account token for this. And I can, unsurprisingly. So I'll copy that. And I'm going to come back out of here. I don't need this port tunnel anymore. So I'm just going to edit that kube config that I set up earlier. I'm going to comment out the token that we have been using. I'm going to put in this token, because I'm curious who this is. And now if I do a get pods, I can see pods in the default namespace. So this is a service account for the default namespace. That's very interesting. And we see that we have somebody who's running the web admin pod in the default namespace. So let's see what I can do is in that space. So let's do the same auth. Can I list? And this time we'll use the token that we just grabbed. I have in the default namespace all resources, all verbs. So I pretty much have full reign, free reign in the default namespace now. All because of an initial app vulnerability that allowed me to get the token for a namespace that allowed me to, as you can see, the dominoes fell, and now I'm expanding the blast radius of what I can do. So we know now we have a default namespace. Oh, I skipped it. The fact that I was able to run nmap not only means I was able to get root in there, but I also that plus the fact that I was able to get out to the Google with curl tells me that my network firewalls, my network policies either don't exist or are way too loose. Network policy in Kubernetes allows you to tightly control the TCP and UDP traffic coming out of and into any pod. So egress out of these pods is wide open apparently, or it's fairly wide open, enough so that I could get all this kind of access. We set up the tunnel. We know that this pod that I was at, that we now know that it's in the default namespace. And given that information, the next thing I'm going to do is, do you remember earlier I showed you this manifest. This is that non-root privileged manifest. I'm going to try this one in the default namespace now. So this again is standing up our Snyk container. What I didn't talk about before is what it's going to do. Because it's privileged, it's going to try to mount, well, we'll just see it. It's going to mount the host volume, host top level volume, to a volume inside the container. And anyone who knows anything about containers in Linux probably is guessing what I can do with this, but I will show you. And I don't want to run it in secure. I want to run this in default. It says it created it. Let's see. It's running. So let's exec into that. Not in a namespace. And this is the Snyk, or excuse me, Okay, now I'm in here. I am the Snyk user still. But the next thing I'm going to do is, sorry, I'm checking my notes, make sure I'm not skipping anything here. We know I can sudo because I have escalation. So even if, well, anyway, so I can do that. PSAX. So I'm in a container, so all I can see are the processes in the PID namespace this container has. However, if you understand how Linux processes work, or not CD, sorry. If I use chroot and set that aptly named chroot mount, that is now my root file system. And if I do that PS again, I can see all the processes on the host. And I'm basically root on that host now. I own this host. I can do pretty much anything I want. And this is using a container and manifest that I crafted and injected in. Again, another reason network policy is important. You shouldn't be allowing containers to be pulled from Docker Hub in this case, or anywhere other than your own manifest, or your own registries. Sorry. Okay, so we now have privileged access to the host. This means that the PSP basically isn't restricting anything in the default namespace. The fact that I was able to do these things there is not uncommon because, again, the developers aren't going to care much about the default namespace generally because they care about their application's namespace, the service accounts for it, and it's usually up to your cluster admins, your cluster ops, to lock down the default namespace and make sure nobody's using it, or if they are going to use it, that it has appropriate restrictions added to it. So where can we go from here? So this is bad already, but I promised you an own of the cluster, not just the hosts on the cluster. So let's go a little farther. Now, while I'm on here, let's see. Conveniently, I have kubectl available to me in this Snyk pod. So I am going to do things, but obviously, if I try to get something, let's try to get pods. I don't have a context set, and I don't want to mess with creating one because there's already one available to me. If I export kube config equals what does every node in a cluster have? Kubelet. And it has its own context. So if I say, I can't use my K alias because I'm not on my machine anymore. If I use that, I can call the API server impersonating the kubelet now. And I can get pods. I can get pods also in kubesystem. So that's the control plane pods. This is getting interesting. I can even, not just pods, I can get at the nodes. I can start looking at those and seeing what's available in those if I wanted to. So now we have access to the kube system from a pod in the default system. And you can see where I'm heading there because you can see the etcd logo there. What's in kube system? etcd. What's in etcd? Everything you probably ever wanted to know. So let's take a look at, I'm going to kind of cruise through a couple things here because I know I don't want to use up all my time. If I describe the etcd control plane pod, I can see a lot of things in here that are useful to me. I can see where it's running is the main thing I care about at the moment, and that is going to be blind kind control plane. So, and I can also see the IP addresses and other things about where the certs are for it and everything else. So let's back out of my sneaky pod. And the next thing I want to do, all the way out, there we go, is I have another manifest. I won't open it because it's not, well, yeah, I will. I'll show you later. I've got an etcd client YAML that's going to go get the standard etcd image. It's going to mount, it's going to start up on the node. I've already typed this in, so I didn't have to type it in. Based on what I saw in that describe, I say, okay, run on the node that etcd is running on, and mount its certificates, basically, so that I can get access to it. And I set up all these values so that I can get access. So we're going to apply this. There it goes. And kget pods. There it is. So now let's see if it's connecting. So I'm going to exec into that and ask etcdctl to do a member list just to see if I've got connectivity. And sure enough, I do. Now, what do you want out of etcd as a hacker? Most likely, the first thing you want, secrets, of course. So there's all the different kinds of secrets. The one I'm interested in, though, now is the cluster, there it is, cluster role aggregation controller token. So if I come in here and I'm going to change my git to get that specific secret, there's that token. And I'm going to copy it. And let's see what I can do with that token using our handy CANI list. Token equals. This is telling me that I have RBAC authorization. This is the cluster token. This is the cluster admin token. I now own the cluster. Anything I want to do with this cluster, I can now using this credential. So this is pretty much, this is admin rights. I own the cluster, starting from an app vuln through all these different little bits. I got to where I can own this cluster. And oh, my animation started early. It's not supposed to start on that one. It's supposed to be the Pac-Man. There he is. That's game over for your cluster. I can turn this into a bit mining cluster. I can do nearly anything I want to do here. So well, we're running low on time, so let's just wrap this here with so I can get to any questions if you have any. So how could we have prevented all this? So obviously, vulnerability in the initial application was the most glaring issue. So scanning your applications and its libraries is the first thing you probably want to tackle. So you're not deploying applications with these kinds of vulnerabilities in them. Next, scanning your container images is critical for similar reasons. Vulnerabilities that you bring in from a base image or from OS level packages you're installing on top of that image can build that kind of a thing right into your into your app, even if your app itself doesn't have a vulnerability. And other vulnerabilities besides RCE are important to worry about as well. Things like directory traversal. I could get at environmental variables and tokens through simple directory traversal vulnerabilities as well. Through you can get your variables through like the proc file system, things like that. Finally, making sure your Kubernetes settings are hardened against these kinds of things all these things we talked about today, not only adds another layer of a protection against vulnerabilities like this that may slip through, or maybe they're a 0-day and there is nothing to scan, no scanners know about them yet, but it also is a great way to train your teams on these tactics and help foster a culture of security. So if they know about these things, they'll think about it the next time they write a deployment or the next time they deploy a cluster. They'll think, oh, don't let people deploy into default and set up policies to keep people from doing things that they shouldn't be in there. Now, before I run out of time, I just want to first give thanks to all of the stuff you're seeing here. We glean from the community that do Kubernetes security. A lot of great things about working. I get to work a lot with the CNCF teams like SIG Security, Tag Security, and other teams like that. And everybody that contributes is very generous with their information. In particular, a lot of the stuff we put this to talk together with includes information from people like Mark Manning, Ian Caldwater, Duffy Cooley, people in the SIG security group. There's a Kubernetes book club that Carlos Santana and I run. So thank you to all of you. If anyone's watching this recording after this or happens to be on this call, thank you for helping put this kind of stuff together. And with that, I think I have, oh wow, I hit the 45-minute mark. So if you have any questions, I don't see any in the Q&A panel yet, and I haven't been able to track chats. So if you have questions, feel free to fire them at me, and I will repeat that the slides I presented and the recording of this are going to get emailed out to you. As well as if you follow Eric Smalling, I'll go back to the top. So that's, if you follow Eric Smalling, I will post to SlideShare these slides to my Twitter and LinkedIn feeds, so you can get those. But I'm here for any questions if you have any. Otherwise, I'm just going to hang out with you, and we got 15 minutes to stare at each other. Thank you. All the thanks coming in. Thank you. Thank you all for attending. I had a mad rush to get this working because, like I said, I found some issues with Apple Silicon or ARM with Kind. And actually, if you want to join me in the Kubernetes Slack and the Kind channel, I'm going to be talking about those in the next couple of days to try to see if we can figure out if it's my problem or pod security policies don't get applied well in Kind on M1. So thank you for everybody for all the kind words in chat. Yes, Emmeline, if I pronounced that right, sorry if I didn't. The recording will go out via email. Thank you. Not seeing any questions come in. Oh, let's see. Are some of the instructions available as a gist or GitHub? Yes, that's a great question. So the repository I use for this demonstration is public. I will tweet that out as well. I've got a few things to clean up in it based on some of the things I saw today with M1. But as soon as that's cleaned up, I will add that to the tweet thread that the slides go out with. Thanks, and I'll make sure that that gets added to the slide, like the last slide. So thanks for asking. And all you need to do this demonstration is, as written, is Docker Desktop and Kind, or any Docker or container. You can even do it with Containerd, I guess. But Kind is what I use to do this because it's easy to stand things up. You should be able to do this on any Kubernetes cluster, honestly. The managed ones are a little more difficult because they actually do apply good security policies to their out of the box to their control planes. So this exact demo might not work in, say, EKS. But other ones can. Again, vulnerabilities combined with misconfiguration feed a lot of the famous incidents we've seen over the years, regardless of who runs your cluster. Oh, cool. I think that's gonna wrap then. If nobody has any questions. I will let my moderators take back over.
All right, well, thank you everyone for attending today's webinar. And with that, we'll go ahead and close out. If you have any other additional questions for Eric, he has definitely given you multiple ways to reach out to him. For those who have been an attendee based on VIB's emails, please expect your gift card within the next 7 business days. And thank you again all for attending. And with that, have a great rest of your day, everyone. Take care.
Bye, everybody.